Hi, welcome to AB Video 3.3b Part 2, the graph of f to the graph of f prime to the graph of f double prime and the reverse. 59 through 64, now we're going to get, some of you are going to be very good at this and others you're going to struggle with this, so pay close attention. It says the graph of f is shown, so they're giving you the graph of f. They're asking you to sketch, which means it's just going to be an approximate graph, to graph the derivative of f. Okay, so here's what our f function looks like. So when you look at that f function, of course, you're going to need to figure out when is f increasing and decreasing, because that'll tell you when f prime is positive or negative. Turns out in this particular graph, f is increasing the whole time. The implication of that, okay, is that f prime obviously therefore is positive the whole time. If f is increasing on this interval, then f prime is positive on that interval. So we now know that our graph is totally contained above the x-axis. Our graph of f prime, there's nothing down here. All our f prime values are positive. Now, the other thing we have is that this is obviously a line. If it's a linear function, you could imagine that the derivative of a linear function is going to be the slope of that line. So really, my derivative function is going to be a horizontal line. Like picture if this was y equals 3x plus 5, the derivative would be 3. So we're graphing f prime of x equals 3. But in our case, the slope of that line, you can actually figure it out using y2 minus y1 over x2 minus x1. It turns out that the slope of that line is 2. And therefore, f prime of x is equal to the horizontal line y equals 2. Okay? 62, same thing. Here's the graph of f. You'll notice that the graph of f is increasing from here to here and again from there to there. So you'll see that the graph is increasing. Let me do this. From negative 1 to 0 and again from 1 to infinity. The graph is decreasing from negative infinity to x equals negative 1. And again, it's decreasing from x equals 0 to x equals 1. Remember, when f is increasing, f prime is positive in that interval. When f is decreasing, f prime is negative. So I actually know, just if you look at the stripes, I know that between negative 1 and 0, all my values for y prime are positive, so none of them are negative, so I'm kind of eliminating this area. Also, between 1 and infinity, all my f prime values are positive, none of them are negative. Similarly, between negative infinity and negative 1, which is in this interval, all my f primes are negative, so none of them are above the x-axis, and again, between 0 and 1, there's none above the x-axis. Now I also know, as you can tell, there's relative extremas here. There's two relative mins, one at x equals negative 1 and one at x equals 1, and there's a relative max at x equals 0. And it's very obvious to tell that the derivative at those locations is 0. So what happens is that means that f prime of negative 1 equals f prime of 1 equals f prime of 0. All these slopes are 0, so all those are y values. On the graph of f prime at negative 1, 1, and 0, we have basically an x-intercept. So we have those 3 points, and that's where I got those 3 points. And then basically just draw stuff in the blank areas, the areas you haven't crossed off. This graph down here shows you, I don't know what's happening in between. I don't know if it goes up a little bit or a lot, and you won't know that until much further. 65 through 68, now you've been given the graph of f prime. You're going to have to pay very close attention to which graph they're giving you. This time they're giving you the graph of f prime right here. They want you to identify the intervals on which f, not f prime, f is increasing or decreasing, and then estimate the values of x at which f has a relative max or min. So this is how it works. I'm going to just erase this whole thing. All right. Now remember, f is going to be increasing when f prime is positive. If you look at the graph, f prime is above the x-axis, i.e. positive, to the left of 0 and to the right of 1. So f prime is positive to the left of 0 and to the right of 1. We know that f will be decreasing when f prime is negative. Well, this is f prime, and notice it is negative between 0 and 1. So you can actually make a number line out of this and go, oh, look, f is going from increasing to decreasing, so f has a relative max at 0, and then f is going from decreasing to increasing, which means f has a relative minimum at x equals 1. Number 68, here's the graph of f prime. So you can see that f prime of negative 1 is 0. That's a point on the graph of f prime. Well, that tells you that negative 1 is a critical number of f because it makes f prime equal to 0. Now you'll notice the graph of f prime itself has a vertical asymptote at x equals 0, and that means that f prime of 0 doesn't exist because there is no point on the graph of f prime with an x-coordinate of 0. Now that means that one of two things. Either f has a critical number at x equals 0 because it makes the derivative non-defined, but it could be that f of 0 doesn't exist at all, which means f is discontinuous at x equals 0, which means it might have a vertical asymptote there, it might have a point discontinuity there, it might have a jump discontinuity, you really don't know. Okay, so looking at the graph of f prime, we can see that f prime is decreasing from negative infinity to, you can see that f prime is negative below the x-axis between negative infinity and negative 1. You can see that f prime is above the x-axis from negative 1 to 0 and again from 0 to infinity. So positive, positive. Well, if f prime is negative, f is decreasing. If f prime is positive, f is increasing. Obviously, since we're going from decreasing to increasing, we'll have a relative min at x equals negative 1. Here we're going from increasing to increasing, so there's no relative max at all. Putting all that together, we have a relative min at x equals negative 1. I don't know negative 1 what, but I do know that it has no relative max. And I know there's a horizontal tangent line there because f prime of negative 1 is 0. So the slope to f of x at negative 1 is 0. So I have this horizontal tangent line. I know there's a min, so it's got to look like this. I also know that f prime of 0 does not exist. Okay, so I'm interpreting this as there's a vertical tangent line at 0, but you really don't know what's going on. It could be one of many things. Okay, these questions again are interesting. Number 71 to 76, assume f is differentiable for all x, and they're giving you the signs of f prime. F prime is positive, negative, positive on these various intervals. Supply the appropriate inequality sign, so they want you to put a less than, a greater than, equals, for the indicated value of c. It's an inequality, so it's either less than or greater than. Okay, so we're going to do, so it's the same thing. Now, first of all, as soon as you see this, f prime is positive in that interval. Well, if f prime is positive, that means f is increasing in this interval. F is also going to be increasing in this interval. However, here the first derivative is negative. That means f will be decreasing in that interval. So you already know where f is increasing and decreasing. Now, if it's increasing on the left of negative 4 and decreasing on the right of negative 4, then there must be a relative max on f at x equals negative 4. You'll notice on either side of 6, f goes from decreasing to increasing, so f must have a relative min at x equals 6. So here's number, let me actually pull this down. Here's number 72. They tell you g of x equals 3 times f of x minus 3. And therefore, g prime of x is 3 times f prime of x, and then minus, the derivative of 3 is 0. And you'll notice number 72 is asking you g prime of negative 5 is what? Greater than 0 or less than 0. So g prime of negative 5 will be 3 times f prime of negative 5. And although we don't know what f prime of negative 5 is, we do know that at negative 5, which is between negative infinity and negative 4, we know the first derivative is positive. That's all we know. Well, obviously, positive 3 times a positive will give a positive, and therefore g prime of negative 5 is greater than 0. And 88 through 92 is previously learned material. It's really, we've done this already. You're given a position function. They ask you to find the velocity function. Then they ask you when is the particle moving in the positive direction, i.e. to the right. And you remember that's when the velocity is negative. And this is the same thing we've been doing. The function f is positive, moving to the right, when its derivative is positive. Okay, so f is increasing when its derivative is positive, f is decreasing, which for position means moving to the left, when its derivative, the velocity, is negative, and obviously it changes directions when the velocity is 0, and you can actually see that it changes from. And that's the end of video 3.3b, part 2.